Hello viewers, I hope all of you are fine. Today I want to demonstrate you a very basic and very simple experiment related to the fluid pressure, and in fluid especially I want to talk about the liquid pressures. You people know very well that liquid exert pressure on an object when we immerse that object in that particular fluids. So now today I want to demonstrate a very basic and simple experiment related to the liquid pressure. We know that basically liquid exert pressure on an object when we place that object inside the liquid at depth h, and the pressure of the liquid on an object inside the liquid depends upon its depth. So you people see very clear here that basically there are three holes in this plastic bottle, and all of these three holes are at the same depth, means h is the same. So must remember the formula P is equal to rho gh for this particular experiment as well, as h is constant. That's why when I fill this bottle with liquid, then you people see that from all these holes the liquids that is immersed out is basically covered equal distance. So now let's demonstrate that. So in this simple demonstration, first I want to fill this bottle. When I fill this bottle, and then after that when I place it vertically, then you people see very clear in that case that the liquid will cover equal distance, because all of these holes are at the same depth. That's why the liquids immerse out from all of these three holes covered the same distance. So this is the first demonstration. Now after this I want to cover the two holes with plastic tape, and then after that I want to show you that now there are three other holes which are at different depths. You people see very clear here that there are almost four holes, and all these four holes are at different depths. So as the depth of all of these three to four holes are different, so the liquid that is immersed out from the deepest hole is a faster and cover a greater distance compared to the other rest of the three holes respectively, because the deeper hole is basically at more depth according to P is equal to rho gh, and that's why the pressure of the liquid that is above that deeper hole is much greater than the rest of the 3 to 4 holes. So let's now demonstrate this second one here. So for that I want to fill this bottle again, and then I want to place it vertically in order to demonstrate that. Now you see very clear that the deepest hole, the water immersed out from the deepest hole is covered much greater distance compared to the other one holes, and the main reason for that is basically the pressure at the depth is much greater compared to the higher points. So again you people see very clear here that the pressure at the depth is much greater. That's why the liquid cover greater distance at the depth compared to the other one holes that are at a higher points, because the pressure above is smaller compared to the pressure at depth. So now what are the application of this particular phenomena and of the formula P is equal to rho gh? So one of the basic application of this is basically the submarine. When the engineers and scientists design the submarine for particular, for example military, then for that they must keep some particular precautions and some particular measurements according to the formula P is equal to rho gh. For example, when they construct the submarine, then they apply a particular pressure, and to know about the how much pressure this submarine can support. So that's why for example if they know about the pressure, that how much pressure this submarine can support, then after that they immerse that submarine inside the fluid, and they can easily be found the depth, such that how much this submarine can be go deeper inside the ocean, according to the P is equal to rho gh formula. If we know P, we know G, and we know H. G is already known because, for example, in case of water, we know that the density of water is 1000 kg per meter cube, and we already know the pressure, we already know the value of G, so we can easily find the depth H of the ocean for submarine, in order to know that how much it can be go deeper without any damage, or without any damage to its particular design. So thanks for your time. This is the one of the basic video regarding to the